Well, thank you all very much for inviting me to participate. I'm going to talk a little bit about some sustainable cogeneration applications, and I'm excited to be here both on behalf of the Cogen World Coalition and the Combined Heat and Power Alliance, which is the organization in the United States that focuses on cogeneration and combined heat and power. We've, at the Cogen World Coalition, in recognition of the substantial sustainability challenges, and particularly climate change that we're facing around the world, we've come up with a short statement. Cogeneration is an essential tool to create the more efficient, resilient, decentralized, and carbon neutral energy systems that are being demanded by policymakers, climate science, and people from around the world. So I think that's designed to articulate a vision of where the cogeneration industry will be going over time. And in many cases, as you'll see in a few of my examples here, we are already starting well down that path. So just to think about it at a high level for a moment, combined heat and power or cogeneration offers substantial sustainability benefits. Efficiency delivers significant reductions, reliable heat and power, which is especially important as we face increasing climate-induced extreme weather events and grid disruptions, and the sort of kinds of events that we've seen in Pakistan recently, but elsewhere around the world. CHP is the backbone for many microgrid systems, combining with solar energy and with battery storage, and we're increasingly seeing that around the world too, and is helpful to providing backup for wind and solar energy as it scales up, but offers only energy on an intermittent basis. And then finally, with renewable and low carbon fuels such as biomethane and clean hydrogen, we can really deliver with combined heat and power or cogen very substantial emission reductions of the sort that climate science is demanding. At the Combined Heat and Power Alliance in the United States, we've recently put out a paper looking at the role that combined heat and power and cogeneration can play in helping advance clean hydrogen. There's considerable interest around the world. I know here in the United States, we've had very substantial new policies that have been adopted to encourage the development of clean hydrogen. So we expect that to be an increasing part of how at least this country, but we believe other parts of the world will be thinking about cogeneration and the fuels that it burns. We learned in this paper, consulting with the major equipment manufacturers, that today's existing and newly installed cogeneration equipment can burn anywhere between 20 and 100% of clean hydrogen. There are facilities that are coming online now that are capable of burning 100% clean hydrogen. And I think perhaps that transition will continue. Certainly all systems will be capable within the decade of burning 100% clean hydrogen. And it's important to keep in mind that existing systems also can be converted to 100% clean hydrogen at both a reasonable cost and with minimal downtime while they are undergoing their typical overhauls. I'm going to provide 4 examples of some real-world applications that we're seeing already. Many here in the United States, and I'm sure there would be plenty of other examples that others at this conference could point to, but at least one in the Eurasia region. So let me just walk through those and talk about some of the benefits of them. So in Houston, Texas, the Texas Medical Center has a cogeneration system that generates 48 megawatts of power. It's 100% of the electricity load for their large medical campus. They're extremely, as you can see here in the slide, the largest medical center in the world. But that system remained operational during Hurricane Harvey in 2018 and was able to continue to deliver their medical systems services during and in the aftermath of the storm. So again, that demonstrates the important resiliency benefits that cogeneration can provide, that as we face these extreme weather events, we can continue to make businesses, and in this case, critical infrastructure like a hospital, able to operate. And then, of course, there's a bottom line benefit too. It helps the medical center save $12 million a year, and has been doing so year after year since it came online in 2010. Now to turn a little bit to some of the different fuels that we're seeing. This is a new project that will come online next year. There's a lot of focus here in the United States on using biomethane, or as it's called here in the United States, renewable natural gas. So this is a renewable natural gas or biomethane dairy digester used in conjunction with a natural gas pipeline delivery system. So that renewable natural gas is pumped into a natural gas pipeline, and then waste heat from the on-site CHP system will be routed to the anaerobic digestion for its thermal requirements. And as I say, it's coming online, and we're seeing increasingly more and more projects that take advantage of biomethane that comes from dairy operations, wastewater treatment plants, and landfills. An exciting new project that is starting up here is a hydrogen pilot in St. Paul, Minnesota. It's a 2 megawatt plant. It's a demonstration project, and I think that's the phase that we're in now, to see a lot of demonstration projects on hydrogen to try to see how they work. Project between a district energy system in St. Paul, the community there, and with Caterpillar, the large CHP manufacturer. They're testing out various hydrogen fuel blends to evaluate greenhouse gas emission profiles, reliability, durability, and barriers to adoption. And this is all driven by the local district energy system, which is owned by the community, which is committed to carbon neutrality by 2050, and supported by our US government through our Department of Energy and the National Renewable Energy Laboratory. Exciting new project. I believe it's the first of its kind in the United States, and we'll see more of these coming along, I think, particularly with new policies that have been adopted recently to encourage the research, development, and deployment of hydrogen projects. And of course, one of the things that we keep in mind with respect to hydrogen and combined heat and power, hydrogen, of course, today is not a commercial fuel. Even as its price may fall over time, it's going to continue to be expensive. And therefore, it should always be used, or used wherever it can be, in conjunction with combined heat and power systems that not only would use it efficiently and reduce costs, but enable its use, maximize its use so that we're achieving the maximum carbon reductions. Here's another hydrogen pilot, this in Dubai. The Electricity and Water Authority has installed both a Siemens electrolyzer to create the hydrogen from solar power, and a 2G CHP engine at the world's largest solar park. It's a really big institution. They're aiming to demonstrate how solar energy can be generated and then stored as clean hydrogen and reconverted to energy for other applications on a large scale. It's very similar to a system that has been installed with a local utility in Haßfurt, Germany. And again, I think we're going to see many more of these sort of demonstration projects. And then ultimately, as the demonstration, we learn from the demonstration projects, we'll start to see and hydrogen prices come down. I know that in the United States, the Department of Energy here has a goal to reduce the price of hydrogen 5 times, we'll expect to see considerable progress, I think, along those lines, and that's going to make hydrogen systems more and more competitive and begin to bring in their ability to achieve these much greater reductions in carbon emissions over the time as the world scales up its efforts to tackle climate change and reduce emissions. I know that we think about the important emission reductions that cogeneration systems can offer in the short term, simply because they're so much more efficient than a conventional power plant. I think that's obviously very important, as is the backup that they provide to renewable energy, wind and solar. But I think over the long term, climate science and policymakers and others are going to demand even more from cogeneration systems. And the good news is that we're starting to see these kinds of pilot projects. The equipment manufacturers are responding. And so I think as soon as the hydrogen market is ready for us, the cogeneration community and equipment providers are going to be ready for them. So thank you. I'm happy to have questions emailed to me at this address if there are any questions that people may have. And then that concludes my presentation.
Thanks very much, David. Appreciate for your participation and great presentation.
Great. Thank you, Yavuz. And thank you all very much.